like performance matrix, like safety assurance and the human confidence. And I think you also mentioned for FSD V11, you are guys going to combine the highway and the city as a single stack, and some architectural big improvement. Can you maybe expand a bit on that? Thank you.
Well, that's a whole bunch of questions. Well, we're hopeful to be able to. I think from a technical standpoint, FSD beta should be possible to roll out FSD beta worldwide by the end of this year. But for a lot of countries, we need regulatory approval, and so we are somewhat gated by the regulatory approval in other countries. But I think from a technical standpoint, it will be ready to go to a worldwide beta by the end of this year. And there's quite a big improvement that we're expecting to release next month that will be especially good at assessing the velocity of fast-moving cross-traffic and a bunch of other things. So, anyone want to elaborate?
Yeah, I guess so. There used to be a lot of differences between production autopilot and the full self-driving beta, but those differences have been getting smaller and smaller over time. I think just a few months ago, we now use the same vision-only object detection stack in both FSD and in the production autopilot on all vehicles. There's still a few differences, the primary one being the way that we predict lanes right now. So we upgraded the modeling of lanes so that it could handle these more complex geometries like I mentioned in the talk. In production autopilot, we still use a simpler lane model, but we're extending our current FSD beta models to work in all sort of highway scenarios as well.
Yeah, and the version of FSD beta that I drive actually does have the integrated stack. So it uses the FSD stack both in city streets and highway, and it works quite well for me. But we need to validate it in all kinds of weather, like heavy rain, snow, dust, and just make sure it's working better than the production stack across a wide range of environments. But we're pretty close to that. I mean, I think it's, I don't know, maybe it'll definitely be before the end of the year, and maybe November.
Yeah, in our personal drives, the FSD stack on highway drives already way better than the production stack we have. And we do expect to also include the parking lot stack as a part of the FSD stack before the end of this year. So that will basically bring us to, you sit in the car in the parking lot and drive till the end of the parking lot at a parking spot before the end of this year.
Yeah, and in terms of the fundamental metric to optimize against is how many miles between a necessary intervention. So just massively improving how many miles the car can drive in full autonomy before an intervention is required that is safety critical. So yeah, that's the fundamental metric that we're measuring every week, and we're making radical improvements on that.
Hi. Thank you. Hi. Thank you so much for the presentation. Very inspiring. My name is Daisy. I actually have a non-technical question for you. I'm curious, if you were back to your 20s, what are some of the things you wish you knew back then? What are some advice you would give to your younger self?
Well, I'm trying to figure out something useful to say. Yeah, join Tesla would be one thing. Yeah, I think just generally try to expose yourself to as many smart people as possible. I don't know, read a lot of books. I did do that though. So I think there's some merit to just also like not being like necessarily too intense and like enjoying the moment a bit more. I would say to 20 or 20-something me, just stop and smell the roses occasionally would probably be a good idea. It's like when we were developing the Falcon 1 rocket. and on the Kwajalein Atoll, and we had this beautiful little island that we're developing the rocket on, and not once during that entire time did I even have a drink on the beach. I'm like, well, I should have had a drink on the beach. That would have been fine.
Thank you very much. I think you have excited all of the robotics people with Optimus. This feels very much like 10 years ago in driving, but as driving has proved to be harder than it actually looked 10 years ago, what do we know now that we didn't 10 years ago that would make, for example, AGI on a humanoid come faster?
Well, I mean, it seems to me that AGI is advancing very quickly. Hardly a week goes by without some significant announcement. And yeah, I mean, at this point, like, AI seems to be able to win at almost any rule-based game. It's able to create extremely impressive art, engage in conversations that are very sophisticated, write essays, and these just keep improving. And there's so much more, so many more talented people working on AI, and the hardware is getting better. I think AI is on a a strong exponential curve of improvement, independent of what we do at Tesla. And obviously, we'll benefit somewhat from that exponential curve of improvement with AI. Like, Tesla just also happens to be very good at actuators, at motors, motors, gearboxes, controllers, power electronics, batteries, sensors, and really, like, I'd say that the biggest difference between the robot on 4 wheels and the robot with arms and legs is getting the actuators right. It's an actuators and sensors problem. And obviously, how you control those actuators and sensors, but it's actuators and sensors and how you control the actuators. It's I don't know. We have to have, like, the ingredients necessary to create a compelling robot, and we're doing it. So.
Hi, Elon. You are actually bringing the humanity to the next level. Literally, Tesla and you are bringing the humanity to the next level. So you said Optimus Prime, Optimus will be used in next Tesla factory. My question is, will a new Tesla factory will be fully run by Optimus program? And when can general public order a humanoid?
Yeah, I think we're going to start Optimus with very simple tasks in the factory. Like maybe just like loading a part, like you saw in the video, loading a part, carrying a part from one place to another, or loading a part into one of our more conventional robot cells that welds the body together. So we'll start, just trying to, how do we make it useful at all? And then gradually expand the number of situations where it's useful. And I think that the number of situations where Optimus is useful will grow exponentially, like really, really fast. In terms of when people can order one, I don't know. I think it's not that far away. Well, I think you mean when can people receive one? So I don't know. I'd say probably within 3 years, and not more than 5 years. Within 3 to 5 years, you could probably receive an Optimus.
I feel the best way to make the progress for AGI is to involve as many smart people across the world as possible. And given the size and resource of Tesla compared to robot companies, and given the state of humanoid research at the moment, would it make sense for the kind of Tesla to sort of open source some of the simulation hardware parts? I think Tesla can still be the dominant platformer where it can be something like an Android OS or like an iOS stuff for the entire humanoid research. Would that be something that, rather than keeping the Optimus to just Tesla researchers or the factory itself, can you open it and let the whole world explore humanoid research?
I think we have to be careful about Optimus being potentially used in ways that are bad, because that is one of the possible things to do. So I think we'd provide Optimus where you can provide instructions to Optimus, but where those instructions are governed by some laws of robotics that you cannot overcome. So, not doing harm to others, and you would have, I think, probably quite a few safety-related things with Optimus. Yeah. So, all right, we'll just take maybe a few more questions, and then thank you all for coming.
Questions, one deep and one broad. On the deep, for Optimus, what's the current and what's the ideal controller bandwidth? And then in the broader question, there's this big advertisement for the depth and breadth of the company. What is it uniquely about Tesla that enables that?
Anyone want to tackle the bandwidth question?
Yeah. So the technical bandwidth of the...
Close to your mouth and loud.
OK. For the bandwidth question, you have to understand or figure out what is the task that you want it to do, and what is the if you took a frequency transform of that task, what is it that you want your limbs to do? And that's where you get your bandwidth from. It's not a number that you can specifically just say. You need to understand your use case. And that's where the bandwidth comes from. What was the broad question? I don't quite remember.
The breadth and depth thing. I can answer the breadth and depth, but yeah. I mean, it's interesting. On the bandwidth question, I think we probably will just end up increasing the bandwidth, or which translates to the effective dexterity and reaction time of the robot. It's safe to say it's not 1 hertz, and it's maybe you don't need to go all the way to 100 hertz, but I don't know, maybe 10, 25, I don't know. But over time, I think the bandwidth will increase quite a bit, or translated to dexterity and latency. You'd want to minimize that over time. Minimize latency, maximize dexterity. I mean, in terms of breadth and depth, I guess we're a pretty big company at this point, so we've got a lot of different areas of expertise that we necessarily had to develop in order to make autonomous, or in order to make electric cars, and then in order to make autonomous electric cars. Tesla is like a whole series of startups, basically, and so far they've almost all been quite successful. So we must be doing something right. I consider one of my core responsibilities in running the company is to have an environment where great engineers can flourish. And I think in a lot of companies, I don't know, maybe most companies, if somebody's a really talented, driven engineer, they're unable to actually, their talents are suppressed at a lot of companies. And it's, and some of the companies, the engineering talent is suppressed in a way that is maybe not obviously bad, but where it's just so comfortable, and you're paid so much money, and the output you actually have to produce is so low that it's like a honey trap. So like there's a few honey trap places in Silicon Valley where they're not necessarily, don't seem like bad places for engineers, but you have to say like a good engineer went in, and what did they get out? And the output of that engineering talent seems very low, even though they seem to be enjoying themselves. That's why I call it, there's a few honey trap companies in Silicon Valley. Tesla is not a honey trap. We're demanding, and it's like, you're going to get a lot of shit done, and it's going to be really cool, and it's not going to be easy. But if you are a super talented engineer, your talents will be used, I think, to a greater degree than anywhere else. SpaceX also that way. So.
Hi, Elon. I have two questions. So both to the autopilot team. So the thing is like I have been following your progress for the past few years. So today you have made changes on like the lane detection. Like you said that like previously you were doing instant semantic segmentation. Now you guys have built transform models for like building the lanes. So what are some other common challenges which you guys are facing right now, like which you are solving in future as a curious engineer, so that like we as a researcher can work on those, start working on those. And the second question is like I'm really curious about the data engine. Like you guys have like told a case like where the car is stopped. So how are you finding cases which is very much similar to that from the data which you have? Like so, little bit more on the data engine would be great. So that's it.
Okay. I'll start answer the first question using occupancy network as an example. So what you saw in the presentation did not exist a year ago. So we only spent 1 year amount of time. We actually shipped more than 12 occupancy network. And to have a one foundation model actually to represent the entire physical world around everywhere and in all weather conditions is actually really, really challenging. So only over a year ago, we're kind of like driving a 2D world. If there's a wall and if there's a curve, we kind of represent with the same static edge, which is obviously, not ideal, right? There's a big difference between a curb and a wall. When you drive, you make different choices, right? So after we realized that we have to go to 3D, we have to basically rethink the entire problem and think about how we address that. So this will be like one example of challenges we have conquered in the past year.